Here we are combining like terms. How does this fit into solving equations that are like these? They're a little bit different. And if you know how to combine like terms, then suddenly they're not very difficult. But it all comes down to the skill of combining like terms. So let's take a look at this. Do you remember what terms are? When I give you an expression, can you tell me how many terms there are here? You should see the first term is right here, the second term is here, and the third is right there. We use the plus and minus signs to separate the terms. And at this point, hopefully, you're feeling pretty good about that, and you already knew there were three terms there. But now I'll ask you the question, which one are like terms? So let's just clean off all of that ink, and let's take a look at it. The first term is 5x. The second one is 3. They both have a number. You know, this is a coefficient, and that's a constant. We're okay with those differences, but the first term, the 5x, it has an x in it, it has a variable. This one doesn't have an x. Meanwhile, this term down here, the third one, has an x also. So which are like terms? I would say 5x and 4x. So why? They have x's. I mean, if you're just wanting to look at the easiest way of saying, are they like terms? Well, if they both have the same variable, then by golly, they're like terms. So how do we go about combining them? Well, on this part, you always take a look at the term and look at the sign in front of it. Now, there's no sign in front of that 5x, so that's 5x. I look at the sign in front of that 4x, and it's a minus sign. So basically, I slide this right behind my 5x. So it's 5x minus 4x. You can do this in your head. And because they both have the same x, because they're like terms, I can literally say, well, 5 minus 4 is 1. So you basically just add or subtract your like terms and make sure that your answer has an x on it. So hopefully that explains to you how we do this, but let's go through and let's just practice on combining like terms, and then in just a second we'll come back and we'll solve these two equations. So let's go and combine like terms. Well, here's my first term. This is a 5x. This one's a 7x. And let's put this one that's not a like term in red so we know we can't put minus 3 from these. Um, let's combine. 5x plus 7x is 12x. So it's basically you add the coefficients and then you just make sure it's got the x on there. Now I cannot go through and say 12 minus 3. I can't say it's 9x. I can't say it's 9 because there's no x on this 3. So this is as far as we go. We've combined all the like terms that we can. Let's go to this one. Are there any like terms that I can add to this too? Well, I know it's not the 7x because that's got an x on it. But this 8, well, that doesn't have an x on it, so in reality, the 2 and the minus 8 are like terms. So we would say 2, and we just kind of scoot this minus 8 real close to the 2. We pretend like that 7x isn't even there, and in our minds we go, well, 2 minus 8 is negative 6. And because that plus 7x is not a like term, I just let that sit right there. And there's no need to write this if you can do that in your head. If you need to, that's fine. Let's go on down to this one. Negative 5g. Well, let's look for all the terms that have a g. Well, this one doesn't have a g. It's got a y, so this is not like terms. I can't put those together. But this one, the minus 3g, that's a like term with this one. So what's negative 5g minus 3g? Do you remember our rules? Keep, change, change. So keep, change, change. That would make it negative 8g. So I've combined my two terms that had the g, and it became negative 8g. And then I can just slide the term that's not a like term down here right beside it, and that would be plus 3y. Now, this one's a little bit easier because sometimes they show up side by side each other for the like terms. See how they're similar? They both have the y's. So that just means 4 plus negative 2 is 2y. And I can't minus 3 from that 2y because there's no y on the 3. So I just let it sit like that. That's how we combine like terms. Now, hopefully you feel pretty good about that, and we can move through and use this new skill for solving these equations. We're still going to be saying which side of the equation is the variable on, where there's the x. So I need to get rid of the 3, the 5, and the 10. Before you go and do anything, though, see if there's any terms that you can combine the terms to, like terms. So here's a 10, here's a 5, this one's got an x on it, so that's not a like term. And ignore what's on the other side of the equation. Just focus on the side that has the variable. Well, 10 plus 5 is 15. So by combining these two numbers, we've reduced from having to get rid of 3 numbers down to just 2 numbers. And if you look right now, what you've created is a two-step equation. We now have a variable on the left side that has 2 different numbers on it. So we've got a two-step equation to get rid of those numbers, and we do the same steps that we've always done. But we couldn't do that until we combined like terms. And so x would be negative 10. Let's scoot this one down just a little bit. So on this equation, this is the last one that we'll do. Which side has the variable? Well, it's the left side. And if you look, um, these two are like terms. They both have x's. So 2x plus 3x is 5x. Everything else we've not had to do anything with. Now, because we've combined like terms, we have a two-step equation. We've got to get rid of this 5 that's multiplying and this 5 that's subtracting. And at this point, we get rid of any subtraction and addition first. And so x would be equal to 5. So how does this combining like terms fit into these equations? Basically, before you start solving, just see if there's any terms that you can combine on the same side of the equation. Don't worry about trying to put this 45 with all this stuff on the left side. Focus where your variables are and just combine like terms on that side of the equation. And after you do that, generally you'll get back to a two-step equation. And next lesson, we get to show you distribution, which is pretty nice to know.